Something just died in space and nobody knows why. NASA scientists watched in real time as a mysterious visitor from beyond our solar system broke apart into pieces and vanished. This was not supposed to happen. The object, called 3I Atlas, came from the depths of interstellar space, and it carried secrets that might change everything we think we know about the universe. But before anyone could fully understand what it was or where it truly came from, the object simply fell apart. Scientists are baffled. The questions are piling up faster than answers can be found. Before we dive into video, please subscribe to our channel. When 3I Atlas was first spotted racing through our cosmic neighborhood in September 2019, astronomers thought they had captured something special. This was only the second interstellar object ever detected passing through our solar system. The first one was Oumuamua, which caused a sensation when it appeared in 2017. That cigar-shaped mystery sparked wild debates about whether it could be an alien spacecraft or at least some kind of artificial probe sent by an advanced civilization. While most scientists settled on natural explanations for Oumuamua, the truth is that nobody really knows for sure what it was. And now with 3I Atlas, we have another puzzle that might be even stranger. The story of 3I Atlas begins with its discovery by the Atlas telescope system in Hawaii. ATLAS stands for Asteroid Terrestrial Impact, Last Alert System, and it scans the sky looking for dangerous space rocks that might threaten Earth. But on September 10, 2019, the system picked up something unusual. At first it looked like a normal comet, but as astronomers studied its path, they realized something incredible. This object was not bound to our sun. Its trajectory showed that it came from interstellar space, traveling between the stars before entering our solar system. The designation 3I means third interstellar object, though. Technically, it was the second one discovered after. Oumuamua scientists immediately turned every available telescope toward 3I Atlas. This was a rare opportunity to study material from another star system. Comets are like frozen time capsules, containing pristine material from the early days of planetary formation. A comet from another star could tell us whether other solar systems formed the same way ours did, or if something completely different happens elsewhere in the galaxy. The chemical composition of 3I Atlas could reveal what kinds of elements and molecules exist around other stars. This information would be invaluable for understanding how common the ingredients for life might be throughout the universe. As observations continued, astronomers noticed that 3I Atlas was behaving like a typical comet in many ways. It had a fuzzy appearance caused by gas and dust streaming off its surface as the sun heated it up. Scientists could detect a tail forming behind it. The spectrum of light coming from the object showed familiar signatures of water ice and other compounds commonly found in comets from our own solar system. Everything seemed relatively normal. But then in late March and early April 2020, something went horribly wrong. Multiple teams of astronomers watching 3I Atlas noticed that the comet was getting brighter, much faster than expected. At first, this seemed like good news, because a brighter object would be easier to study in detail. But the brightness increase was happening too quickly. Something strange was going on. Then the shape of the comet started to change. Instead of a single bright nucleus, the images showed the object was fragmenting. 3I Atlas was breaking apart. Over the course of just a few weeks, the comet disintegrated into more than 24 separate pieces. Telescopes, including the Hubble Space Telescope, captured images showing the fragments drifting apart. Each piece had its own small tail of dust and gas. Scientists watched helplessly as their rare interstellar visitor destroyed itself before their eyes. By the end of April 2020, the largest fragments had faded from view and 3I Atlas was gone. The opportunity to study this messenger from another star system had slipped away. The big question that haunts researchers is simple but profound. Why did 3I Atlas fall apart? Comets do sometimes break up, but usually there is an obvious reason. A close pass by the sun can tear a fragile comet to pieces through tidal forces and extreme heating. But 3I Atlas was still relatively far from the sun when it disintegrated. It never got closer than about the distance of Mars' orbit. Comets that break up at that distance are unusual. The sun was not hot enough or close enough to explain the destruction. Some scientists have proposed that 3I Atlas might have been spinning too fast and simply flew apart from centrifugal force. As frozen material on the surface vaporized in the sun, it could have created jets of gas that worked like rocket engines. These jets might have spun the comet faster and faster until the rotation became so rapid that the comet could not hold itself together. This is possible, but it requires specific conditions. The comet would need to be spinning at just the right rate and have just the right structure and composition. Another idea is that 3I Atlas was simply very fragile to begin with. Perhaps it was more like a loose pile of rubble held together weakly by ice, rather than a solid chunk of rock and ice. When the sun began to heat this loosely bound collection of debris, the ice that served as glue between the pieces melted away. Without that binding material, the comet just fell apart. This explanation makes sense for some comets, but it raises more questions about 3I Atlas. If it was so fragile, how did it survive the journey through interstellar space? The journey that 3I Atlas made before arriving in our solar system was incredibly long. Scientists calculated its trajectory backward in time to figure out where it came from. The results show that this comet has been traveling through the galaxy for millions of years. It did not come from any nearby star system that we can identify. Instead, it seems to have originated from somewhere deep in the Milky Way galaxy. For millions of years, 3I Atlas drifted through the freezing vacuum of space, exposed to cosmic radiation and occasional impacts from tiny dust grains. Traveling at high speeds, interstellar space is harsh, and anything traveling through it gets bombarded constantly by radiation and particles. Over millions of years, this bombardment can change the surface chemistry of an object and damage its structure. Some scientists think this long exposure might have weakened 3I Atlas and made it brittle. By the time it entered our solar system, the comet might have been so damaged that even gentle heating from our distant sun was enough to cause catastrophic failure. This is an interesting hypothesis, but it is difficult to test without actually examining pieces of an whole interstellar object up close. The destruction of 3I Atlas has some researchers wondering if this is the fate of many or even most interstellar comets. Perhaps these objects are generally more fragile than comets that formed in our own solar system. If true, this would be an important discovery because it would tell us something about conditions in other planetary systems. It might mean that comet formation around other stars produces different results than what happened around our sun. Or it could mean that the process of being ejected from a planetary system and spending millions of years in deep space fundamentally changes these objects. Comparing 3I Atlas to Oumuamua reveals interesting differences and similarities. Oumuamua never showed clear signs of being a comet. It had no visible tail and no obvious cloud of gas and dust around it. This absence of cometary activity led some scientists to propose that Oumuamua might be more like an asteroid, made of rock or metal rather than ice. However, Oumuamua did show a slight acceleration as it passed through the solar system. This acceleration was small but measurable, and it could not be explained by gravity alone. Something was giving Oumuamua a tiny push. The most likely explanation for Oumuamua acceleration is outgassing. Even though no tail was visible, the object might have been releasing small amounts of gas from its surface as the sun warmed it. The escaping gas would act like a weak rocket engine, giving the object a gentle push. This is exactly what happens with normal comets, and it creates the acceleration that was observed. But if Oumuamua was outgassing, why was there no visible tail or cloud? One possibility is that the gas being released was not the usual water vapor, but something else like hydrogen or nitrogen that would be much harder to detect. Some researchers, including a few respected scientists, have suggested more exotic explanations for Oumuamua. The most famous proponent of alternative theories is Avi Loeb, a Harvard astronomer, who proposed that Oumuamua could be a light sail. A light sail is a large, thin, reflective sheet that can be pushed through space by the pressure of sunlight. Advanced civilizations might use light sails to propel spacecraft between stars. Loeb argues that the odd shape of Oumuamua and its unexplained acceleration are consistent with what you would expect from an artificial light sail. Most scientists are skeptical of this idea because there is no direct evidence that Oumuamua is anything other than a natural object. But Loeb makes a valid point that we should not dismiss possibilities just because they seem unlikely. Now, with 3I Atlas breaking apart in such a mysterious way, some people are wondering if there could be an artificial explanation for this object too. Could 3i Atlas have been some kind of probe that self-destructed after completing its mission? This is the stuff of science fiction, but it is worth considering if only to rule it out. The problem with the artificial probe hypothesis is that 3i Atlas behaved almost exactly like a natural comet, except for its fragmentation. It showed outgassing and a tail made of normal cometary materials. Its composition, as far as scientists could tell, was consistent with natural ice and rock. There is no evidence of any artificial components or unusual behavior beyond the breakup itself. The more mundane explanation is almost certainly correct. 3i Atlas was a natural comet from another star system, and it broke apart due to structural weakness combined with solar heating. This is disappointing for those hoping for evidence of alien technology, but it is still scientifically fascinating. Every piece of data we gather about interstellar objects helps us understand the bigger picture of how planetary systems form and evolve throughout the galaxy. One of the most frustrating aspects of the 3i Atlas story is that it happened during the COVID-19 pandemic. In early 2020, as the comet was beginning to fragment, the world was shutting down. Many observatories closed or operated with limited staff. Planned observations were cancelled or delayed. Scientists who wanted to study 3i Atlas found themselves unable to access the telescopes they needed. Some data that could have been collected was lost forever. The pandemic did not cause 3i Atlas to break apart, but it definitely hampered our ability to study the event in detail. Despite these challenges, astronomers did manage to gather valuable information. The Hubble Space Telescope, which operates remotely from Earth, captured crucial images of the fragmenting comet. Ground-based telescopes that remained operational tracked the pieces as they separated and faded. Spectroscopic observations revealed the chemical composition of the gas and dust being released. All of this data is now being analyzed by research teams around the world. Papers are being published with new findings and theories. The scientific process continues even though the object itself is gone. What have we learned from 3i's Atlas? First, we have confirmed that interstellar objects do pass through our solar system, and probably do so regularly. Before Oumuamua, most scientists thought such visitors would be extremely rare. Now we know that with the right telescopes, we can detect them. Second, we have learned that at least some interstellar comets are fragile and can break apart relatively easily. This tells us something about their structure and composition. Third, we have gathered data about the chemical makeup of material from another star system, showing that it is similar to but not identical to material from our own solar system. The similarities between interstellar objects and our local comets and asteroids suggest that planet formation follows similar rules throughout the galaxy. The basic physics and chemistry that created our solar system also operates elsewhere. This is encouraging for anyone hoping to understand how common planets like Earth might be. If the raw materials are the same everywhere, then Earth-like worlds should be possible around many different stars. Of course, having the right materials is not enough. You also need the right conditions and a lot of luck, but it is a start. Looking forward, astronomers are preparing for the detection of more interstellar visitors. New telescopes and survey systems are coming online that will be able to spot these objects earlier and track them more effectively. The Vera Rubin Observatory, currently under construction in Chile, will scan the entire visible sky every few nights. It is expected to detect dozens or even hundreds of interstellar objects over the course of its mission. When the next Oumuamua, or 3i Atlas, appears, scientists will be ready with better tools and more detailed observation plans. There is also growing interest in sending a spacecraft to intercept and study an interstellar object up close. Such a mission would be extremely challenging because these objects move very fast and their trajectories are hard to predict. A spacecraft would need to be designed to launch on very short notice and accelerate to incredible speeds to catch up with the target. Some concepts involve parking a probe in space, waiting for an interstellar object to be detected, and then firing the probe toward an intercept course. Other ideas include using the sun gravity to slingshot a spacecraft to high speeds, or even using nuclear propulsion for extra thrust. If we could send a probe to an interstellar object and return samples to Earth, the scientific payoff would be enormous. We would have actual pieces of another star system to study in laboratories. The chemical and isotopic composition could be measured precisely. We could determine the age of the material and trace its history. We might find organic molecules or other building blocks of life. We could answer questions that telescopes alone cannot address. Such a mission is probably decades away, but the technical studies are already underway. The story of 3I Atlas is ultimately a story about the limits of our knowledge and our insatiable curiosity. Here was an object that traveled for millions of years across the vast emptiness between stars. It entered our solar system, gave us a brief glimpse of its nature, and then destroyed itself before we could fully understand it. We are left with fragments of data and more questions than answers. Why did it break apart? Where exactly did it come from? What does its composition tell us about other planetary systems? How many more objects like this are out there waiting to be discovered? NASA may not be able to fully explain what happened to 3I Atlas, but the agency and the broader scientific community are not giving up. Every observation adds to our understanding. Every theoretical model gets refined as new data comes in. The process of science is slow and sometimes frustrating, but it works. We know vastly more about interstellar objects now than we did just 5 years ago. In another 5 years, we will know even more. The comparison to Oumuamua is inevitable because these are the only 2 confirmed interstellar objects we have detected so far. Each one is unique, and each one raises different questions. Oumuamua was the strange visitor that did not act quite like a comet or an asteroid. 3I Atlas was the fragile traveler that could not survive its brush with our sun. Future discoveries will add more characters to this cosmic story. Some might be even stranger than what we have seen so far. Others might help us understand the patterns and make sense of the mysteries. What makes these objects so compelling is that they connect us directly to the rest of the galaxy. Most of astronomy involves looking at distant objects through telescopes. We observe stars and galaxies that are light years or even billions of light years away. The light we see left those objects long ago, and we are viewing them as they were in the distant past. But interstellar objects are different. They are here now in our neighborhood. They are pieces of the galaxy that have come to visit us. Even though they originated far away and long ago, they are close enough to study in detail. The mystery of 3I Atlas reminds us how much we still have to learn about the universe. Despite all our technology and all our scientific knowledge, we cannot always predict what will happen or explain what we observe. Nature is full of surprises, and the cosmos is far stranger and more diverse than we imagine. Every time we think we understand something, a new discovery challenges our assumptions and forces us to think harder. Is 3I Atlas the next Oumuamua? In some ways, yes, because it is another interstellar visitor that has captured our attention and sparked our imagination. It is another data point in our growing catalogue of objects from beyond our solar system. It is another reminder that we are part of a much larger cosmic ecosystem where material and objects flow between star systems. But in other ways, 3I Atlas is its own unique mystery. It behaved differently than Oumuamua, and it poses different questions. We should not expect all interstellar objects to be the same any more than we expect all comets or all asteroids in our own solar system to be identical. The universe is vast, beyond human comprehension, and it is filled with wonders we have not yet discovered. 3I Atlas is just one small example of what is out there. As our technology improves and our surveys become more comprehensive, we will find more of these travelers. Each one will teach us something new. Each one will add another piece to the puzzle of how the galaxy works and what kinds of objects exist in the space between stars. The adventure is just beginning, and the best discoveries are still ahead of us.